Okay, with this function, part A asks find the order pair 4 and f at 4. This just means plug in 4 in here and find out the y value. So let's do that. 2, 4, cube plus 1. So that's 2 times by 4 times 4 is 16, times by 4 is 64 plus 1. So that's 128 plus 1, so that's 129. So it's going to be 4 and 129. Part B, find the order pair on the inverse relation that corresponds to the order pair from part A. Okay, this is A. The inverse relation is going to be 129 and 4. Just switch the x and y values. Find the domain and range of f. Okay, this is a polynomial function. The domain is going to be x, all real numbers. Okay. The cubic function, right, starts from a really negative value and goes all the way up. So it actually contains all, right? It contains all of real values for y as well. So domain and range both is the entire set of the real numbers. D, find the domain and range of the inverse function. Well, it just switches, so it's going to be exactly the same. Right, domain and range just means what are all the possible x values and y values. Okay, is the inverse a relation of function? Explain. Okay, so we can actually do some transformation, right? The parent function, let's call it g at x, is x cubed, which looks like this. Okay. So if you take the inverse of this, it's still going to be a function. It's this one here basically stretched vertically and shifted up once. So it's gonna look like this. This graph here is gonna look something like this. Goes a little bit faster, this, right? And if you reflect this on y equals x, because this passes the vertical line test, right? And also passes actually the horizontal line test. So if you do the inverse, the horizontal line test becomes the vertical line test. It's only 1 point for every single y, but it's only 1x. So for that reason, okay, E, the inverse is a function as well. Inverse is a function. I mean, if it was like this, if you inverse that, it's going to look something like this, okay, which wouldn't be a function.